Problem 39th. In this question, we have three subdivisions. Problem number 39. A uniformly charged conducting sphere of 0.6 meter diameter has a surface charge density 5.7 microcoulomb per meter square. We have three questions here. First question, find the net charge on the sphere, and the second question is find the total electric flux leaving the surface, and the third question is what is the net flux through the concentric Gaussian sphere of radius 2 meter. Let's write the given first. So what is given in the question? We have the charge conducting sphere. That means the shape of the sphere, we know it's like a sphere shape. So we have to draw the diagram. This is sphere, and then they mentioned the diameter of the sphere, which is d equal to 0.6 meter. From the diameter we will find the radius, because half of the diameter, which is nothing but the radius, when you divide this number by 2, we will get the radius as 0.3 meter. Clear? And also they said the surface charge density, the charge sitting on the surface of the sphere, sigma value is given, which is 5.7 microcoulomb per meter square. So micro stands for 10 to the power of minus 6. So you have to write the value 5.7 multiply 10 power minus 6 coulomb per meter square. In the first question, we are going to find the value of charge. And in the second question, we are going to find the flux value. And the third question, we have to find the net flux if you increase the radius. That means again we are going to find the answer for the flux. So this time we have to increase the radius of the conducting sphere. And let's answer the first question first. So what we have to find? We have to find the charge. Am I right? So for finding the charge, then we have to use the formula for surface charge density. As we already studied the formula in our theory, the formula for surface charge density, sigma, which is equal to Q over A. Am I right? So the formula for the surface charge density, which is equal to Q over area. What area? This is the surface area of the sphere. When you rearrange this equation, if you rearrange this equation, you will rearrange this equation in terms of charge, because we have to find the answer for the charge first, right? So if you rearrange this, we will get the formula Q, which is equal to sigma multiplied by area. Now we have to find what should be the surface area of the sphere. As we already know, the surface area of the sphere is 4 pi r square. So I have to take this value of A, I have to substitute here. If you substitute, what you'll get? Q, which is equal to sigma multiplied by 4 pi multiplied by r square. As we already know the radius value, we already find the radius from the diameter. So here the radius is 0.3 meter. Now we have to substitute the value in the question, in the equation. Now I'm going to substitute the value. So the sigma value, they gave 5.7 microcoulomb per meter square. So 5.7, this is 5, okay, 5.7, or I can rewrite one more time. 5.7 multiply 10 power minus 6 multiply by 4 pi multiply by our value 0.3 here. So we have to square this number. Let's see what's the answer. 5.7 multiply 10 power minus 6 multiply by 4 multiply by pi with 0.3 square. Here I got the answer as 6.45. So the first question answer Q, which is equal to 6.45 multiply 10 power minus 6, and the unit for the charge is coulomb. So this is the answer for the first question. And second question, we are going to find the total flux phi value we have to find. So as we already know, the formula for the flux phi, which is equal to the charge enclosed divided by the permittivity constant. That means this is the charge enclosed, am I right? So we have to use this formula for the charge here. When you substitute the value of the charge here, 6.45 multiply 10 power minus 6 divided by the permittivity constant value is 8.85 multiply 10 power minus 12. If you divide the first one with the second, that means 6.45 multiply 10 power minus 6 divide by 8.85 multiply 10 power minus 12. Let's see what's the answer. 6.45 10 power minus 6 over 8.85 10 power minus 12. So I got the answer here as 7.29 multiply 10 to the power of 5, 10 to the power of plus 5. But what's the unit for the flux? Newton meter square per coulomb. So this is the answer for the second question. Clear? Now we have to go back to the third question. So here what they mentioned in the third question, again we have to find the flux, but this time we increase the radius of the sphere as 2 meter. Initially the radius of the sphere is 0.3 meter, but this time it is 2 meter. That means we increase the diameter. But if you increase the diameter, how much flux you will get? Because as we already studied, the charge enclosed in the sphere will be same. Am I right? Even if you increase the radius, the same flux will be there. So what should be the answer for the third question? You'll get the same answer like what you get in the second part. So the flux what you got in the second part will be the answer for the third one, which is 7.29 multiply 10 power 5 Newton meter square per coulomb. What's the reason? The reason here is the charge enclosed in the sphere is same, right? In the sphere is same because the charge is not changed, right? So we have the same charge inside the sphere. So that means the flux will be the same even if you increase the radius. So the answer for the third question will be the same answer like what you get in part B. But you have to give the reason. Why? Because the charge enclosed in the sphere is same. So even if you increase the radius double the times or fourth the time or fifth the time, no issue. You will get the same answer as what you got from the